So today we're going to start chapter 3, section 1. We'll begin section 1. We'll do it in 2 days. Tonight's homework is the 3.1a homework on WebAssign. And then on Friday, the homework over the weekend will be 3.1b. So let's go ahead and look at a few forms and some different parts of our quadratics. So the graphs of the quadratic function, that graph or the shape is called a parabola. Now, in our book, this form that's listed here, the ax squared plus bx plus c, our book calls it the quadratic form. Other books refer to it as standard form. So when you're doing the WebAssign, make sure that you understand quadratic form is ax squared plus bx plus c, and it's f of x equals. Now, also in our book calls standard form f of x is equal to a times x minus h squared plus k. So our book calls this standard form. So when WebAssign is asking you to put something in standard form, that's the generic form of it that it's looking for. But when they refer to quadratic form, it's the ax squared plus bx plus c. Now, just some key things to look at from these two forms. So when it's in the quadratic form, the number that's in front of x squared here, when this a value is a positive number, then we know our parabola is going to be a positive parabola, and it's going to be smiling, and it'll be opening upward. When the a value is a negative number, then it would be a negative person, and think of the person as like frowning, and it's pointing downward. So just little things to remember and think about just by looking at that. Now, we already saw the shifts. Remember when it was a negative sign, it was a reflection. So if you think about back to your parent graph of the x squared, it was the U shape, and it was opening upward, but then if there's a negative in front of x squared, we knew that was the reflection. So again, little things to look for. Also, what we can tell when our equation or our function is in quadratic form, the y-intercept is going to be located right here at the c value. This is going to be my y-intercept. So sort of just like your y equals mx plus b. So when it's in the standard form, your y-intercept is going to be that constant that's at the end. Now, for it to be quadratic, we need an x squared term. So that's what this exclusion here says, a cannot equal 0. So you need an x squared term in order for it to be a parabola or to be quadratic. Next, what we're going to do is look at the graph here. So notice in my graph, if we talk about increasing and decreasing, my graph, when it's falling from left to right, this side of my graph here, let me see if I can highlight it in another color. This side over here is the decreasing side of my graph. And over here, this point right here, where it's going to change direction and then start increasing, this is the increasing side, but the point where it changes direction is called the vertex. Now, the vertex is actually an ordered pair. You could think of it as x and y, but if you notice in this equation that I wrote over here, this standard form, in that form, the h and the k represent my vertex. So the numbers that are going to be in those positions, that is going to be my vertex. And the vertex is always going to be used or called HK. Now, when my parabola is happy like this one and it's opening upward, The vertex is a minimum. However, if I have a sad parabola over here and it opens downward, then my vertex here, this would be as high as it gets, and this would be a maximum because it's the highest point that my graph takes. This one's the lowest it gets. This would be the highest point. Now in my graph, if there's like an imaginary line that goes through that vertex, so if I zoom in here, this green dashed line here, this is called the axis of symmetry. So if you think back to when we talked about symmetry, in the notes I told you that parabolas always have y-axis, the parent parabola always has y-axis symmetry. If I were to take my parabola and fold it up, that would be like a line of symmetry there. Now, in this case, it's not symmetrical about the y-axis because my vertex is not at the origin. My vertex is actually the order pair here of -1, 0. That's my vertex. And again, that's my h and my k value. The axis of symmetry, this green dotted line, I can abbreviate it as AOS. This is actually an equation. So don't tell me it's just going to be -1. It's actually a vertical line, and it's the equation x equals -1. The way that we would get that number, it's always the x or the h of my vertex, and it's always x equals. If you do not write the axis of symmetry as x equals a number, you're going to get points off if you don't write it as an equation when you take the quiz next week. The quiz next week will not be a Canvas quiz. It will not be multiple choice. You are going to be completing the square, and you're going to be finding all these different points that I'm going to talk about today. You'll be finding the axis of symmetry, the vertex, the x-intercepts, the y-intercept. You're going to be finding all of these pieces of the parabola. So again, remember your axis of symmetry, it's always going to be an equation, and it's always going to be x equals a number. You must write it as an equation. The vertex will be an order pair. The y-intercept will be an order pair, and so will the x-intercepts. So let's go ahead and follow the steps on the next slide for graphing an equation in quadratic form. So the steps are going to be as follows. We're going to find the vertex, and there's a formula to find the vertex, and that formula is x is equal to -b over 2 times a. Then once we find that x value, then we're going to plug it back into the equation to get the y of our order pair. My next step will be to plot the y-intercept, and then I'm going to look for additional points. I can find the x-intercepts, and then I'm also going to use my axis of symmetry to get the other side of my U-shape. So to get additional points, I'm going to use my axis of symmetry. When you plot the y-intercept, remember we're going to look at the c value of our quadratic form. And again, it'll be an order pair, and it's 0, whatever that c number is. Remember, again, you're going to be seeing it as f of x equals something. Remember, f of x is just the same thing as saying y equals. So let's try some examples of graphing these. So for the first example, it's got f of x is equal to 2x squared. Now, I could do the parent, and then I could just stretch it. This is actually a vertical stretch when the number in front of x squared is greater than 1. I'm going to go ahead and just find my vertex and find my all my points this way. Now, I could do a table, but let's go ahead and practice using the formula to find the vertex. So the first thing we're going to do is find the vertex by using x is equal to negative b over 2 times a. Now this is in the quadratic form. However, my a value is 2. I do not have an x term, so b is 0. And c, there's no constant, it's also 0. So when I plug it into the formula, I'm getting negative 0 over 2 times 2. 0 divided by anything is 0. So here, my vertex is x equals 0. And then if I plug in the 0 into the f of x original equation, remember this is y equals, so 2 times 0 squared just gives me a y value of 0. So my vertex is located at the order pair 0, 0. Notice there's no c here either, so my y-intercept in this case is also 0, 0, because there's no c. Another way to find intercepts, remember we can plug in zeros. So far all I have is this. So what I'm going to do to get my other additional points, I'm just going to do a little table here. Normally, we can actually just find the x and the y-intercepts. But in this particular case, my x-intercept and my y-intercept, they're both the same as the vertex. Okay, so I'm going to plug in negative 1, 0, and 1, just like I did before when we did those parent graphs. So again, here is your equation. 2 times negative 1 squared, 2 times 1. So I can graph the order pair negative 1, positive 2. Going to do the same thing here. This gives me 0. I already did this one, 0, 0. And then when I plug in 1, 1 squared is 1. So 2 times 1 is 2. So my other order pair here is going to be 1, 2. So I can now graph those. And 1 and negative 1, positive 2. And positive 1, positive 2. So here is my parabola. When I connect them, remember you're going to take a U shape. And that is the graph of f of x equals 2x squared. Now, if it asks you to identify your axis of symmetry, remember it's going to be this line that goes through the vertex. And it's actually the y-axis here. And again, it's always the x of the vertex. So my x of my vertex is 0. So my axis of symmetry is going to be x equals 0. So in this particular problem, my axis of symmetry is x equals 0. My y-intercept is 0, 0. My x-intercept is 0, 0, and my vertex is 0, 0. Now, you could have also done this comparing it to the parent. Again, because it's a vertical stretch, it's going up 2 times as fast. Now, the other one, number 2, we're going to do the same thing. It's going to go up half as fast, and that's a vertical shrink. All right, so let me graph example 2. This get a little bigger here. Okay, so again, I'm just going to go ahead and make a table. Realize that when the number in front of x squared is less than 1, this is a vertical shrink. And this is going to go up half as fast as, say, the parent. So let me just do a little table here and get some ordered pairs and graph it. So again, when it's basic like this, it's easy enough to just do this. When they get more complicated, that's when we're going to use some of the techniques coming up. So negative 1 squared is just 1. A half times 1 is a half. And then when I plug in 0, 1/2 times 0 squared is just 0. And then 1/2 times 1 squared is just 1/2 times 1, and it's 1/2. So the 3 order pairs I can graph are -1, positive half, 0, 0, 1, and then the half. So let me put those on here, and you're going to see that it's a vertical shrink. It's getting wider. So 0, 0, and then -1, and then the half, and then +1 and a half. And you can see it's getting wide. So that would be just go ahead and graphing it, the same techniques that we've had before. So for number 3, again, we could either apply this as a shift from the parent. Again, if you're going to do it that way, the negative sign indicates that this is a reflection. The 4 indicates that this is going to be a vertical stretch. And it's going up 4 times as fast as the parent of x squared. So again, for questions like this, I'm just going to do a table of values. And what I can do is x and then -4x squared, plug in -1, 0, and 1. -4 times -1 squared just gives me -4. Then when I plug in a 0, that gives me 0. And then when I plug in a 1 and square it, I still get -4. So the 3 order pairs I'll graph are -1, -4, 0, 0, and 1, -4. So I'll go ahead and plot these. This is actually my vertex. And I can show you how we can get that as well with the -b/2a. So plot 0, 0. Do different color. And then -1, -4. And then here. And again, if you think about it, the parent would have been up here. And then the negative sign in front was the reflection. And then you also had to apply the stretch. So the final graph here is that red. Now, if you wanted to use the -b/2a to double check that that 0, 0 was your vertex, again, the equation was y equals -4x squared. Again, my a was -4, b is 0, c is 0. So if it doesn't have an x term or a c term, your vertex is always going to be at that origin. So -0, which is just 0, over 2 times -4, 0 divided by -8, and the x of my vertex is 0. And then when I plug in a 0 for x, I still get the y of the vertex to be 0. So this is why my vertex is at the origin of 0, 0. We're going to do the same thing on number 4. We're just going to do a table, and then we're going to graph it. So let me go ahead and do number 4 here. So again, I'm just going to do a table. Again, notice the negative sign here in the front. This is indicating that it's going to be a reflection from the parent. And then the 1/4 tells me that it's going to go 1/4 as fast as the parent. So again, let me just get some order pairs here. And again, y equals -1/4 x squared. Just plug in these 3 numbers again. -1/4 times -1 squared is just going to give me -1/4. And then -1/4 times 0 squared is just 0. And then -1/4 times 1 squared is just -1/4. So the 3 order pairs that I'll graph are going to be -1, -1/4, 0, 0, +1, and -1/4. And you're going to see that it's a reflection from the parent. So it'll be a sad parabola here. And then again, I'll graph -1. And again, it's kind of hard when they're fractions like this, but it's just super wide now. So let's go ahead and look. Now this is what our book calls standard form. Again, other books call this vertex form. We are going to be using completing the square to change our quadratic form into this standard form. Again, remember the letters H and K in this standard form represent the vertex. Now, when you pull the H out, it's opposite of what you would think. The K is going to keep the sign because the formula, that subtraction sign between that X and that H, that's there. It's a subtraction sign. It's not necessarily the sign on the H. And then the line of symmetry, again, is an equation, and it's whatever the H value is of the vertex. So for example, if I said f of x is equal to x minus 2 squared plus 5, right here, this is my H, this is my K. So when I go to pull out my vertex, the H is opposite of what you think because this subtraction sign here, it's not a negative sign, it's a subtraction sign. So my H value is actually a positive 2. And then my K is the sign that's there. So my vertex is 2, 5. My axis of symmetry is going to be x equals 2. If I have something like this, f of x is equal to x plus 4 squared minus 1. This is H, this is K. When you pull out the H backwards of what you think, because what really went in here was negative, negative to make it a plus. So my vertex is actually negative 4, negative 1. And again, my axis of symmetry is going to be x equals negative 4. So what we're going to be doing here is completing the square to get it into this form. However, if it's already given to you in the form, you don't have to complete the square. It's only when it's going to be in quadratic form, the ax squared plus bx plus c, that we're going to need to conform it or turn it into this standard form. For the first example, it's already in the standard form. So I'm going to pull out my vertex first. So remember, your H is here, your K is here. So my vertex, the H comes out as backwards of what you think. So it's negative 2, but the K is the sign that's there. My axis of symmetry, I'm abbreviating that as AOS, is going to be the X of the vertex, and it's an equation. Do not tell me that the axis of symmetry is negative 2. You must write it as an equation, and it's a vertical line, and it's X equals negative 2. Now, to find my y-intercepts and to find my x-intercepts, when it's given to you in this form, we have to plug in zeros. Now, that 3 that's there is not the y-intercept. Okay, the constant is when it's in the quadratic form, when it's the ax squared plus bx plus c. So in order to find intercepts, to find the y-intercept, I need to set x equal to 0. So this is all going to be things you're going to be asked to find on the quiz next week. I'm going to ask you to find a vertex, the axis of symmetry, your y-intercept, and the x-intercepts, and then I'm going to ask you to graph it. So let's go ahead and work on finding the y-intercepts. So I'm taking my original equation, and again, remember, f of x is just a fancy way of saying y equals. So I could really say this is y equals x plus 2 squared minus 3. I'm going to replace x with a 0. So y equals, and then I'm going to do 0 plus 2 squared minus 3. I'm going to follow order of operations. So I'm going to do the parentheses. Then I'm going to do the exponent. And then I'm going to subtract. So the order pair for my y-intercept is the order pair. I plugged in a 0, and then I got a y as the answer. So this is my y-intercept. Now I have to find the x-intercept, and I'm going to find that by setting y equal to 0. So to find your x-intercept, I set y equal to 0. So 0 equals x plus 2 squared minus 3. I'm going to be using my square root method. I'm going to isolate that square term by adding 3. And now I'm going to square root both sides. I get plus and minus the square root of 3 is equal to x plus 2. I'm going to subtract 2. And I have an x-intercept at -2 plus or minus root 3 equals x. They're going to probably ask you to write them as coordinates. So you're going to write -2 minus root 3, comma 0, and -2 plus root 3, comma 0. These are my x-intercepts. Okay, so now that I have all these pieces, so again, on the quiz next week, you're going to have to find everything that I just boxed here. The x-intercepts, the y-intercept, the axis of symmetry, and the vertex, and you're also going to have to graph it. So let's go ahead and put all of this on our little graph here. So I'm going to graph my vertex first. My vertex was the order pair -2, -3. And then I'm going to graph my y-intercept, which is the order pair 0, comma 1. And now how Marcus just said, Marcus said he was going to use his axis of symmetry, which is this imaginary line here that goes through your vertex. And I can already connect my vertex to my y-intercept. And this is going to be the right side of the U. And what I can do to get the left side, you see how this y-intercept is 2 spaces away from that line of symmetry? I could come over here 2 spaces, and I can put another dot, and then I can connect the side. And there's my parabola. Now, just to double check that I've made it the appropriate width and everything, I could go ahead and double check my x-intercepts. Now again, we're not using a calculator yet for the parabolas, but remember your 2 x-intercepts were these. And if I approximate the value of the square root of 3 to be about 1.7, so if I take these 2 order pairs, the -2 minus root 3 and -2 plus root 3, -2 minus 1.7 gives me about -3.7, comma 0. And then over here, the same thing, add that, and I get -0.3. And then if I come and look, well, look where my graph hit. This looks like it's probably about -0.3, and this looks like it's probably about what did I say it was? -3.7, because it's almost to the 4. So I did a pretty good job here. So honestly, as long as your y-intercept and your vertex are 2 different points, you could just graph those 2 and then use that axis of symmetry and reflect it to get the 3rd point. Now, if it's looking for a more specific width on it, then you would have to plug in additional points. It's already given to you in this standard form, we're not going to need to complete the square. But when it's given to you in quadratic form, like the next example, you are going to be required to complete the square first, change this quadratic form to standard form and then do everything that I just did for example 5. So let's go ahead and complete the square. Now we're going to do completing the square a little bit differently because now we have a y term involved. Before we were just solving for x. So this time it's going to be a little bit different. Now, some of you may learn it a different way. I don't care how you get to your standard form, but you have to complete the square. Whether you move it to the other side, I'm not going to move my constant to the other side. I'm just going to work with everything on this same side of the equal sign and shift it over. Sort of like what I did before. So what I've got here is f of x is equal to, and I'm going to shift over my constant so I can leave. And actually, I'm going to change this to a 4. Does your notes have a 4 or a 14? 14. All right, change it to a 4. Okay, so what we're going to do here is I'm going to leave a blank space, and I'm going to move the 4 over. Now, same thing that you did before. You're going to take your b term, divide it by 2, and square it. So negative 3 squared, and I get 9. Now, remember when I did this, when I put in this blank space, I didn't put plus 9. I put what I got when I divided by 2. So I'm putting it in as a negative 3 squared. Now, normally when you complete the square, we should be moving the constant to the other side. So what we would be doing to the other side is also adding 9, but because I didn't move it to the other side, instead I'm subtracting 9. So when you square it, normally you would be adding 9, but because I didn't move it, I'm going to subtract 9. And now what I'm going to do is I'm going to factor my trinomial, and then I'm also going to combine these like terms here. So I'm going to end up with f of x equals x minus 3 squared. And then when I combine those like terms, I get minus 13. And now it's in the standard form. This is my h, this is my k. So now what we're going to do is the vertex is equal to 3 and negative 13. Remember, the h is opposite of what you think. Now, because my original problem was in quadratic form, I can get my y-intercept, and it's this c value here. So I don't have to plug in the 0 into my newly formed standard form. I'm just going to take it from the beginning, and my y-intercept here is going to be 0, negative 4. To find the x-intercept, I'm going to use the newly formed standard form because it's easier than trying to factor or doing the quadratic formula. So let me go ahead and use this one to find the x-intercept. I'm setting y equal to 0, which is the f of x. So 0 equals x minus 3 squared minus 13. Going to add 13. 13 equals x minus 3 squared. Use your square root method. And I get plus and minus 13 equals x minus 3. And now move the 3. 3 equals plus and minus 13 equals x. So my two x-intercepts are at 3, and this needs to have a radical, sorry. The 13 has a square root, comma 0, and 3 plus square root of 13, comma 0. These are the x-intercepts. An example of using completing the square. So let me go back and highlight everything that you need to include in your answer. So in your answer, you're going to have, and I also need to add in the axis of symmetry. So you would be giving me the vertex. Let me go ahead and add in the axis of symmetry. So axis of symmetry is going to be x equals 3. So we're going to give that as an answer, the y-intercept as an answer, and the x-intercepts. So all of this will be required to put on the lines as well as to also graph it. So let me go ahead now and graph this. And then I'm going to also show you how we could have also gotten all this information by not putting it into standard form, by leaving it in the quadratic form. So let me go ahead and graph all of this. And again, I don't need to graph the x-intercepts. I could just graph the vertex and the y-intercept and use the axis of symmetry. So if I graph my vertex is, and I'm going to go by 2s so it doesn't go off the graph here. So let me change this scale and make these are 2, 4, 6, 8. So my graph should be at, my vertex should be at 3, negative 13. So negative 2. So my vertex is actually way down here in the middle of the box for 3 and then negative 13. So this order pair is 3, negative 13. And then my y-intercept was at 0, negative 4. I could draw in my axis of symmetry. It's going to be this vertical line through the vertex. So again, I can connect this side of my parabola. And then I can do like a reflection. So you can see that this y-intercept is like 1.5 away. And then over here, I can put another point to get this side of the graph. And then there would be your parabola. So really all you need to plot is the y-intercept and the vertex if they're two separate points, and then use the axis of symmetry. And I missed that third point. Let me do that better. And then that would be your parabola. So it's got to hit the reflection. Now, if you don't want to do this, you could also plug in additional points or even figure out where your x-intercepts are located. Now, another way we could have also done this same problem, if we didn't want to convert it to the standard form, we could have also worked with it and used the negative b over 2a. However, on the quiz next week, you will be required to complete the square and to get it into the standard form. So let me go ahead and try and show you that way as well. So if my original function was f of x is equal to x squared minus 6x minus 4, another way to find the vertex is to use the x equals negative b over 2a. Your a is 1, your b is negative 6, and your c is negative 4. So to get the vertex by using this, I would do opposite of b, so it'll be positive 6, 2 times 1. So the x of my vertex is 3. Then you take this 3 and you're going to plug it in for x up here to get the y. So if we do y equals 3 squared, 6 times 3 minus 4, follow PEMDAS. Y equals negative 9 minus 4, and then the y is negative 13. So we can get the vertex this way without completing the square. So this would be a way that you could double check your answer. However, you must show the work for completing the square on the quiz next week, Without it, you will get that part of the question wrong. Now, in order to find the y-intercept, again, it's the c, so we really didn't have to do any work for that. However, to find the the x-intercepts, because this is not factorable, which is the fastest way, I either have to go now and complete the square or do quadratic formula to get the x-intercepts. So I already did completing the square. Let me go ahead and do quadratic formula to get the x-intercepts. So again, x-intercepts, you set y equal to 0. I'm going to do quadratic formula. B equals -6, C equals -4. So when I plug it into the quadratic formula, 6 plus or minus -6 squared minus 4 times A times C, all divided by 2 times A. So 6 plus or minus 36 plus 16, 6 plus or minus the square root of 52. I need to break down the 52. It's 4 times 13. This becomes 2 square root 13. Do not be tempted to simplify until after you break down the radical. Now I can reduce, make these 1s, make this a 3, and it's the same answer I got when I used the vertex form by using the square root method. So the same thing that I got over here, I'm now using quadratic formula. So again, we can still find all of the same answers without completing the square. However, on the quiz, you will be required to complete the square. Let me see if I can get another example in. Okay, so the next example, I'm going to complete the square. And again, I'm finding the vertex, axis of symmetry, x-intercept, y-intercept, and then I'm graphing it. So again, when you complete the square, you can't have a number in front of x squared. So I need to divide everything by -1 or factor out a -1. So I'm going to factor out a -1. This is going to tell me the direction of my parabola. He's going to be sad. So x minus 6x plus 8. And then now what I need to do is, actually I'm going to move, I'm going to move the constant first. I'm not going to divide out a -1 from that. Let me back up here. I'm going to move the constant first. So this becomes a -6, leave the blank space, and I'm moving the 8. I'm not dividing it by -1. So then now what I'm going to do is take the b term, divide it by 2. So -6 divided by 2 squared gives me -3 squared. So what I should be subtracting over here is a -9, but I have to consider, since I didn't divide it, I have to take the -1, multiply it by the -9 that I should be putting over here. So I'm really adding 9 here. And in here, I'm going to put the plus -3 squared. So now I have f of x. I'm going to factor it, and it turns into x minus 3 squared. I need to combine -8 plus 9. That gives me +1. I now have it in vertex form. You don't need to leave the -1, just leave the negative sign. So now my vertex is the h and the k. So it's 3 and 1. My axis of symmetry is x equals 3. My y-intercept, I can go back to the original, and it's right here. So it's the order pair 0, -8. To find the x-intercept, we're going to set y equal to 0. And I'm using my vertex form, or my standard form. So I'm going to be doing 0 equals negative, and then x minus 3 squared plus 1. Move the 1. -1 equals negative x minus 3 squared. I gotta isolate the square term, so divide both sides by -1. This becomes +1, x minus 3 squared, square root both sides, plus and minus 1 equals x minus 3. I need to move the 3. Now, because there's no radical, I actually have to do the problem here. So I have to do x equals 3 minus 1 and 3 plus 1. So my x-intercept is 2, 0 and 4, 0. Okay, so these are now my x-intercepts. So now I have all the pieces I need. I have my y-intercept, my axis of symmetry, my vertex, and then these x-intercepts. So now I can come and put all of these pieces on my graph. So again, I can graph the vertex first. So my vertex was 3, +3, +1. My y-intercept is -8. So it goes off the graph, it's way down here. And then I could draw in the axis of symmetry, and I can actually get away with just using these 2 points. So again, if you notice, this is 3 spaces away. I can come over here 3 spaces away and put in my 3rd point. And I can connect it and make my parabola. And then come over here as well. And there's your parabola. Notice the negative in front of x squared in the original problem indicated that it was going to be a reflection. So again, notice my x-intercepts that I got here, these 2 order pairs, were actually where my graph touched. 2, 0, 4, 0. So those were my x-intercepts, my y-intercept. To get this additional point, I used the axis of symmetry, and I also graphed the vertex. So you will need to be able to demonstrate all of this technique on the quiz next week. Okay, so now let me go ahead and do number 8 and number 9, and then I'll finish the rest of the examples in the video that I'm going to make on Friday. So again, for number 8, what we're going to do is complete the square. So there's no number in front of x squared, so I'm good there. So I'm going to shift the constant over to the right. And again, I need to take the b term, divide it by 2, and square it. I get -2 squared, which is +4. So if I would have moved that constant to the other side, then what I would have been doing is adding 4 to it, but since I didn't move it over, I'm going to subtract 4 here, and then in here, I'm going to put what I got when I divided by 2. So again, I'm going to factor that, and it'll factor into x minus 2 squared. Then I got to combine these. This gives me a -1. It's now in the standard form. I can pull out my vertex, my h and my k. So my vertex is located at +2, -1. My axis of symmetry, remember, is an equation, and it's x equals that h value. And then for my y-intercept, I now can just go back to the original and take the c value. So my y-intercept is the order pair 0, 3. Now, in order to find the x-intercepts, this is where I'm going to set y equal to 0, and I'm going to use my newly formed standard form and plug in the 0 there. And then that's how I can get my x-intercepts. Okay, so the next thing we need to do is find the x-intercepts of our equation, and I'm going to use my newly found standard form, and I'm going to set y equal to 0. So I'm going to do 0 equals x minus 2 squared minus 1. I'm going to isolate the squared term by adding 1. And now I need to apply the square root method. I'll square root both sides, and I end up with plus and minus 1 is equal to x minus 2. Add 2. And I get 2 plus and minus 1 equals x. And now I make two problems. X is equal to 2 minus 1, and x is equal to 2 plus 1. This gives me 1. This gives me 3. My two x-intercepts are 1, 0, 3, 0. So now I found all of the pieces that I need to graph my parabola. I have an x-intercept, a y-intercept, the vertex, and the axis of symmetry. So I'm going to get all of this information put onto my graph. So let me go ahead and graph the vertex first. It's the order pair +2, -1. I'm going to graph my y-intercept, which was 0, +3. Now, technically, I don't even need to graph the x-intercepts. I could just go ahead and put in my axis of symmetry here. And my parabola is like a reflection. And I can go ahead and connect my points and make the left side of my parabola. And now I can use the line of symmetry. This point is 2 spaces away. I could go 2 spaces away over here and then get a third point to graph my parabola here. Now notice when I connected that point to the reflected point, notice my x-intercepts were the order pair 1, 0 and 3, 0, which is where my graph touches the x-axis. So that is the graph of the equation x squared minus 4x plus 3. Again, your axis of symmetry is that green line. Let me do one more example, completing the square, and then getting all the components to graph it. So again, I am going to make sure that my A value here is a 1, and it's not. So I'm going to go ahead and factor out 2. I'm also going to shift that constant to the other outside of the parentheses. I'm now going to take my B term, divide it by 2, and square it. I get 4. 4 squared. I did not divide that 8 by 2. Let me fix that. This is a 4x. So up here, my B term is now 4. So 4 divided by 2 is 2, and 2 squared is 4. So in here, I always put what it was before I squared it. And over here, I have to take into consideration the 2 that I factored out. Normally, I would be subtracting the 4. So I'm going to multiply 2 times -4, and I get -8. So that's what I'm going to combine over here. I need to factor this perfect square trinomial, and this ends up becoming 2, and then a parentheses x plus 2 squared minus 1. I now have it in standard form. I can pull out my vertex. It's the order pair -2, -1. My axis of symmetry is x equals -2. For my y-intercept, I can go back up to the beginning. It's just the c. So my y-intercept is the order pair 0, 7. And now to find my x-intercepts, I need to set y equal to 0. And again, I'm going to use my newly formed standard form. It's a lot easier. I can just use the square root method. Now, if my original function could have been factored, I would have factored that. I could have also done quadratic formula to find the x-intercepts. But again, it's a lot easier just to use my vertex form. And again, I'm going to set f of x, which is really y, equal to 0. In order to use this square root method, I need to isolate the square term. So I'm going to add 1. 1 equals 2 times x plus 2 squared. Divide by 2. 1/2 is equal to x plus 2 squared. I apply the square root method. I get plus and minus 1 over 2, x plus 2. I can't leave a radical in the denominator, so this was actually going to turn into this. I have to rationalize this by multiplying the top and the bottom by the square root of 2. So that simplified rational 1/2 radical becomes square root 2 over 2. So now I have plus and minus square root 2 over 2 is equal to x plus 2. Isolate x by subtracting 2. Negative 2 plus or minus square root 2 over 2 equals x. So my two x-intercepts are going to be the ordered pairs negative 2 minus square root 2 over 2 comma 0 and negative 2 plus square root 2 over 2 comma 0. These are your x-intercepts. And now I'm going to go ahead and graph all of the pieces that I found. My x-intercepts, my y-intercept, my axis of symmetry, and my vertex. So now that I've found all the pieces of information, my x-intercepts, my y-intercept, my axis of symmetry, and my vertex, now I can graph all of these pieces of information. So the first thing I'm going to do is graph the vertex. Okay, so the first thing I'm going to do is graph a vertex. It's located at the ordered pair negative 2, negative 1. Then I'm going to graph my y-intercept. It's at 0, 7. And then I'm going to add in my axis of symmetry, which is going to be this imaginary line that goes through the vertex at x equals negative 2. And now I can use the reflection of across that axis of symmetry to get my points. Now I could also approximate my x-intercepts as well. But let me go ahead and connect. And there's your parabola shape.